Alright, so I finally decided to quit teaching the prereq skills, and so this is section 1.1 in your textbook. If you want a textbook, just ask me, I'll get you one, if you're in my class, right? So the vocabulary here, average rate of change, which is just another way of saying slope. I do use a slightly different formula, but average rate of change is just a more sophisticated way of saying slope. That's all it is, nothing more. Interval notation, which we've been doing as we've been learning our mother functions. Maximum is literally the max y value on a graph. That's all it is. And minimum is simply the minimum y value on a graph. And I say graph or a function. Of course, set builder notation is something we've been doing. Zero of a function is a very good definition. Zero of a function is literally where the output is equal to 0. And when I say output, I mean y is equal to 0. We also call these, and this is what they are, x-intercepts. I don't know if I talked too much about zeros throughout this lesson. Sometimes I forget about it. Of course, your I-CAN statement is interpret key features of linear, quadratic, and absolute value functions given an equation or a graph. I tried to cut these notes down. I think the original slides was like 20-something. I can't do that in a day. All right, understanding domain and range. An air tanker flies over forest fires and drops water at a constant rate until its tank is empty. What are the domain and range of the function that represents the volume of water the air tanker can drop in x seconds? Now, it says it drops it at a constant rate, which makes me think that this is a linear function. And I'm going to go back to 8th grade with y'all, and we're going to write an equation for it, because it is. It is dropping 400 gallons per second, and that would be a slope. And we should probably do this volume as a function of x instead of y equals. Volume as a function of x. The rate of change is that we lose 400 gallons per second, and we initially started with 8,000. Now that's the idea here, okay? What are its domain and range? Okay, well, let's take a look at a graph of this. And I'm just going to pull up Desmos instead of freehanding this thing. And you can probably come up with this logic in your head too. How long it takes to actually drop 8,000 gallons of water. It should say y equals, not 7 equals. And of course, if you just do that, you don't see anything. But what I'm interested in is like, when does this thing run dry? So here's the, the actual scenario there. But the function ends here. It takes 20 seconds for it to run out of water. So the domain for this thing would be x, which is time, 0 to 20 seconds. That's all it contains. You have 20 seconds of water. And Desmos may not have done the best graph. Maybe if I change this to be in thousands or something. Let's see here, the y-axis. Let's change the step to be 500. That did absolutely nothing, did it? Maybe I change the step to be 1,000. Let's go from 0 to 1,000. 0 to 3,000. Oh, we had 8,000 gallons, didn't we? 9,000. And you can kind of see a better picture here, but let's change the step again to be 2,000. You just zoomed too far out. So there you can see, and we run out of water right there, 20 seconds. Okay, anyways, my bad. But anyways, the domain here is that this function is valid anywhere between 0 and 20 seconds. At 0 seconds, we have 8,000 gallons of water, and at 20 seconds, we're out of water. The range, which is the water that remains inside the air tanker, you actually start with 8,000, but the low value is 0. But anywhere between 0 and 8,000 gallons of water. Real world application domain-ish, kind of. I don't know. All right, find the x and y intercepts. So if you don't remember how to find an x-intercept, this is for you. To find an x-intercept, which is also called a zero of a function, we let y equal 0, because anywhere on the y-axis, x is 0. To find a y-intercept, which we don't call anything other than a y-intercept, we let x equal 0. All right, so we're going to find the x-intercepts of y equals the absolute value of x minus 3 algebraically. And we simply do that by setting the function equal to 0. Okay? Now, with absolute value, you isolate the absolute value equation, and then you write two equations. One of them is as is, and on the other one, you change the sign on the stuff inside. So 3 is x, or 3 is negative x. And this one's already solved. I know it's backwards to you, but it's already solved. It says x is 3. This one, if we divide out the negativity, says negative 3 is x. So our x-intercepts happen when x equals 3 or negative 3. And to be thinking about ordered pairs here, we let y be 0, right? So think about your ordered pairs as well. All right, find the y-intercept algebraically. Here we just let x be 0. Remember, that's what we just wrote down, let x equal 0. So it would say y equals the absolute value of 0 minus 3. Now, I don't know what your IQ is if you don't know the absolute value of 0. But if you don't know the absolute value of 0 is 0, that IQ, you struggling. Y is negative 3. Especially, if this is the first time you ever heard of absolute value, like if you're sitting at home and you're in 3rd grade, you've never heard of absolute value, we don't expect you to know what it is. But I teach juniors, and if a junior doesn't know what absolute value of 0 is, how did you make it to your junior year? Like, this is one of the worst things we do in education is constant promotion. You shouldn't have been promoted. You should have been held back. That's the reality of it. You need to be held accountable for things you know. Anyways, that tells me y is negative 3. Now, if we think about our ordered pair, this happened when x was 0. All right, what is the minimum value of y equals the absolute value of x minus 3? Now, big deal with me is graphing, okay? And this is something we should be able to graph. I say we should. If you're in my class, we've been doing this for a minute. Looks like a V. Think about this as the absolute value of x plus 0 and then minus 3. It's in the form of a times x minus h plus k. So we just shift down 3, and then we have an initial slope of the understood 1. Rise 1, run 1. Now, the minimum value of the absolute value of x minus 3 is negative 3. The minimum equals negative 3. Notice I didn't talk about x. The minimum is the y value. Remember that? It's the low y value. It does happen at x equals 0. It does happen there. That's one of the vocab terms. You know, what's a min, what's a max? Now, my wife is texting me, so let me pause this real quick and see what she needs. Be right back. All right, so this in class would be a you try, okay? But, you know, you're watching a lecture online. So what are the x and y intercepts of g of x equals 4 minus x squared? Again, we're just going to write down what we know. To find an x-intercept, we let y equal 0. All right, so g of x is fancy for y. 0 equals 4 minus x to the second. And you've had Algebra 1. You're supposed to know how to solve something like this. We're going to shift x to the second to the left. Leave the 4 on the right. Now, you need to be asking yourself, what's the opposite of squaring? And the opposite of squaring is square rooting. Now, there are two numbers in existence that when squared give you a 4. They are plus and minus 2. Because if you take a negative 2 and square it, you get a 4. If you take a positive 2 and square it, you get a 4. So the x-intercepts, and again, think about your ordered pairs, they were at 2, 0 and negative 2, 0. All right. Now, finding a y-intercept is going to be way easier on this one because of what you're replacing with a 0. To find a y-intercept, we just let x equal 0. So g of x, which is fancy for y, is going to be 4 minus a 0 squared. And 0 squared is still 0, so it's just y equals 4. So, again, your ordered pair here, we let x be 0, and we found that y is 4. Now, what is the max value of g of x, and where does it happen? Just refer to a graph, okay? Let's rearrange this thing so it looks a little more like your form. It would be negative x squared plus 4. And that may not quite look like your form. You can think of it like this: negative x plus nothing squared plus 4. And then it does line up with your form a times x minus h plus k. Now it's a square, so it's the parabola. I've got a handful of kids who hadn't quite figured that out. We've been doing this for a straight week, and you ain't figured out that x squared looks like a parabola? Like, you're telling me how much attention you're paying, and you're telling me not just how much attention you're paying, you're telling me how much you care. And here's what you're going to do. You're going to come crying to Milbrath the last week of every 6 weeks saying, what can I do to improve my grade? You can start caring on day 1, and you can keep caring all the way through. If you don't like your grade, make it a priority. It ain't my priority, it's a you priority. My job is to hold you accountable. You need to get that in your head. Anyways, where was I? See, I was ranting. Okay, so k is 4, we rise 4. Put a dot. Negative, we're going to fall 1, run 1, because there's also the understood 1 idea, right? Fall 1, run 1. And there is my parabola. So this point obviously is going to be the max. And the maximum y value is 4. And it happens on this particular one at x equals 0. Now, don't look at these notes and think that I'm going to get a maximum value by plugging in a 0. That's just the way these functions are. This is an introductory section, okay? So it ain't supposed to be too hard. It's just to get the stuff in your head. All right, here we have positive or negative intervals. For what intervals is f of x equals x squared minus 9 positive? For what intervals is the function positive? And we are going to do a rough graph. This again is a parabola. To graph it, all we have to do is shift down 9 units. And we're going to take it a little farther than that. You know, it's really easy to find x-intercepts. Let's find the x-intercept. We let y be 0. 0 equals x squared minus 9. We add 9 to both sides. The opposite of squaring is square rooting. And anytime you take the square root of a number because you're solving for x, 2 means 2 solutions, you have to include the plus or minus symbol. So we have an intersection or an x-intercept or a 0 at both 3 and negative 3. I wish I had more curvature on that. I did a bad job on the curvature. But that is a rough graph. Now, let's talk about what it means to be positive and negative. Okay, what do they mean by that? So, for a function to be, the positive part of a function is that which lies above the x-axis. The negative part is that which lies below the x-axis. Okay? That's the difference between positive and negative. Because if you're positive, your y values are, if you're above the x-axis, your y values are positive. If you're below the x-axis, your y values are negative. So the positive intervals, which are the intervals, again, that lie above the x-axis, I actually wrote that in there for you, are there and there. Now, this interval starts when x is negative 3, and it runs left to negative infinity. Now, the reason I use the parentheses is because at this point, I have a y value of 0. That's why I did that. All right, the negative interval, union with, which means and or, the other positive interval, which starts at 3 and runs right to infinity. The negative intervals are the intervals that lie beneath the x-axis. And that particular interval, the left boundary is negative 3, the right boundary is positive 3. So it looks like that, negative 3 to 3. Now, if you're a fan of set builder, because some people are, all values of x such that x is less than negative 3 and x is greater than 3. You can do a compound inequality. On the interval for being negative, sorry, I had a brain fart there, it would be all values of x such that x is literally stuck between negative 3 and positive 3. You know, a handful of kids like inequalities and they like interval form. If you're that kid, good. Be both, actually. Understand them both. They're not that bad. All right, here's a try it. For what intervals is h of x equals 2x plus 10 positive? For what intervals is the function negative? You ought to be able to graph this thing. Like, this is straight up 100% all day long mx plus b. Right? Now, I need to have some more room here. It crosses the x-axis at 10, 5, 6, 7, 8, 9, 10. And its slope is to rise 2 and run 1. And that's just not going to do me much good. Or fall 2 and run 1. Now, it's going to be hard to pinpoint where you cross the x-axis on a freehand graph. So remember, to find an x-intercept, we let y equals 0. So we're going to replace that piece right there with a 0. 0 equals 2x plus 10. It's a two-stepper. Subtract 10. Negative 10 equals twice x. Divide by 2. X is negative 5. 2, 3, 4, 5. That is a very key point, because to be positive or negative, you are going to be positive, you're going to be above the x-axis. So let's talk about positivity. This is the positive interval, and that interval starts at negative 5, and it continues on to the right forever. Okay? To be negative means to be below. That interval actually starts back at negative infinity, and it runs right until it hits negative 5. If you're a set builder kid, all values of x such that x is greater than or equal to negative 5. If you're a set builder kid down here, all values of x such that, nope, I don't need the equality symbol. X is less than negative 5. It should be a parentheses. Down here, all values of x, boy, that's a bad curly brace, such that x is less than negative 5. All right, moving forward. For what values of x is g of x equals 2? Take away the absolute value of x increasing and decreasing. So I've got it written down here what increasing and decreasing mean. Increasing means positive slope, decreasing means negative slope. And remember, absolute value of x is a v. Now this particular v opens down. Now, one side of that v is going to be increasing, the other side is going to be decreasing, because remember, we read from left to right. So it says construct a table, but, you know, whatever. I guess we can do a table. Let's just do our usual negative 1, 0, 1. Now, if I feed this one out negative 1, I'd have 2 take away the absolute value of negative 1, which is just 2 take away 1, which is 1. This would be 2 take away the absolute value of 0, which is 2. This will be 2 take away the absolute value of 1, which is, again, 1. Huh, who would have thunk? I would have done shifts, okay? Rise 2, put a point, slope is negative 1, fall 1, run 1. And there we go. Now, positive slope is increasing. We are increasing. This guy is uphill. Remember those things? So we are increasing from negative infinity all the way until we hit this x value of 0. Negative slope is going to be your downward slope. This guy, that's downhill. And we start going downhill when x is 0, and we keep going downhill forever. It's a long ways down. It was a long ways up, and it's a long ways down. Whew. These notes are taking longer than I anticipated. And this should be the last one. And there's not anything in here, so I'm going to have to make something up. All right. So the whole point of this slide is to introduce the formula for average rate of change. And the formula for average rate of change is simply f of b minus f of a, sitting pretty, over b minus a. So I'm just going to make up a question real quick. It ain't going to be anything too bad. Alright, so what is the average rate of change for f of x equals 4 minus, need more line there, for f of x equals 4 minus x to the second over the interval, let's do something like negative 1 to 3. Okay. Now, you get the letters a and b from the interval. These are actually x values. So there's a, there's b. If I want to find f of b, what I'm going to do is I'm going to plug a 3 into my equation. It's going to become 4 minus a 3 that is squared. Notice my usage of parentheses. All right, 4 is 4, 3 squared is 9, 4 minus 9 is negative 5. If I want to find f of a, everywhere I see an x in my equation, I'm going to be plugging in negative 1. Now pay attention again to the usage of parentheses. You have to learn when to use parentheses. Now if you square a negative 1, you get 1. So this is 4 minus 1. And 4 minus 1 is 3. And then you just feed this formula up here, okay? It's f of b minus f of a. So it's going to be a negative 5. Let's just go back up here and plug in. F of b was negative 5. We're taking away f of a, which is 3. And we're sitting pretty over b minus a, which is 3. Take away a negative 1. A lot of kids, if they see a minus in the formula, will not write the negative number. They'll just make it, they just only want to put one sign down. Anyways, negative 5 take away 3 is negative 8. 3 take away negative 1 is 4. Negative 8 over 4 is negative 2. So on average, as we move from left to right, from negative 1 to 3 from our x values, the average rate of change is negative 2. And we know that these are parabolas. Okay, parabolas don't have a constant slope, but we have an average slope. And there you go. There is section 1-1. Right now, that's really just for one kid that I've got at home. But if you needed the notes, there you go.